SIMD Part 4, let's do the cross product. In the previous video, we saw that they give us a nice handy-dandy dot product function. Alas, we don't have as easy a time doing cross product. But they do give us something that we're going to need. They give us something that's called a shuffle. What's a shuffle? A shuffle is just a way to rearrange a vector. Vector made of x, y, z, and w. The shuffle instruction is going to let us just mix and match it. We could reverse it. We could do x, x, y, y. We could take z, do what's called a broadcast z across a whole vector, that kind of thing. Just rearrange the vector any way we want. Here's the intrinsic for shuffling. And you'll see once again, like with the dot product, we have a mask. I'm not going to actually describe precisely how the mask works because they've given us a macro to make the mask for us in this case. So this macro is a little weird though because it goes W, Z, Y, X. And because of that, I've provided an alternate macro. This is the one we're actually going to use. This is going to be in your header file somewhere. And it lets you go X, Y, Z, W. So how do we use it? The X, Y, Z, and W are all going to be integers from 0 through 3 that tell you for the output vector, where do you want to get the input? We're going to take an input vector like an A, and we're going to return some parts of the input vector. So for the X of the output, which part do we want that to come from the A? That's what this means here. And for the Y output, what part of A do we get it from? For the Z output, right? And these are integers, so what we're actually going to say, we're not going to be able to say X, Y, Z, unfortunately. We have to say 0, 1, 2, 3. So this is 0, this is 1, this is 2, this is 3. So let's just run an example. So say, for example, I want my C vector to come out from the A. I want to take from the A, and I want to take the X component and put the X component into the X. I'm going to put the X component into the Y, X into the Z, and X into W. So it's like a broadcast. I just want to take the X component and broadcast it across the whole vector of C. And this is how I would do that, right? I would use the shuffler macro and just put 0, 0, 0, 0, which stands for X, 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 right? Let's do a few more examples. How about we're going to broadcast Z? We're going to take from A.Z, we're going to take A.Z and put it in all four terms of the C vector. So we'll use the shuffle PS intrinsic, and we'll use the shuffler macro, and this time we'll just say 2, 2, 2, 2, because Z is 2. It's 0, 1, 2, 3. So we just shuffle 2, 2, 2, 2, and we get a bunch of Z's. Or how about let's reverse it. Let's take XYZW from WZYX. So again, we use the shuffle. Use the shuffle with the shuffler macro, and this time we just say 3, 2, 1, 0. So it says, I want my X to come from W. I want my Y to come from Z. I want my Z to come from Y, and I want my W to come from X. And we reversed it. Okay, now, before we go through this slide, take a moment. Don't worry about it. We're not going to do this. I'll jump right here. I'm not going to do this in the lab. I'm not going to ask you to know about this slide on the exams. But you will be confused probably if you haven't noticed already. The shuffle PS intrinsic takes two input vectors as well as the mask. Now, what's going on with that? Well, for those of you who are curious about it, the X and the Y components of the result come from A, the first one, while the W and the Z component come from the second argument. Why? Honestly, I don't even know. I don't think I've ever used that. And we are not going to use that in this class. So every time you need to use this shuffle PS macro, it'll always be the same vector repeated twice for A and B, so you don't have to worry about this detail. All right. So now that we've seen shuffle, let's see if we can make a cross product out of it. Here's the floating point form of cross product, right? It's just written out there. It's a bunch of multiplies, some subtracts. How can we vectorize this? Well, we could write this equation. If we had, instead of having ax, ay, az, if we instead had ay, az, ax, then we could do this as a single vector multiply and then a vector subtract. And here's a vector multiply. We could turn this into two vector multiplies and one vector subtract if we could just rearrange the vectors. So we can use shuffle to do that. So here's how you'd go through it. We need to make this vector, I'll call this temp A, just by taking A and shuffling it to make it that. And here's temp B, we'll need a shuffle for that. Now we can multiply those two. And we'll need to make this one, we're done with temp A now, so I'll just call it temp A again. Temp A comes from this, temp B comes from this, we multiply them, and now we can do a single subtract to subtract those two.